Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. This is lecture number 62 of Physics 5054. Ladies and gentlemen, in the last lecture, I told you that the next topic is a secret one. Yes, today we are unveiling a very important topic, and that is the boiling point and condensation. They are the opposite of each other, as was the case in melting point and solidification. Solidification was the reverse process of melting, and if you remember, I told you that at whichever temperature melting point is occurring, that point will be the solidification point as well. Similarly, today we will observe that the point at which the boiling is occurring will be the same as the condensation point. What is boiling point and what is condensation point? Let's start the topic. First of all, if a pure substance is heated at a particular temperature, it changes its state from liquid to the vapors or gas. This is called boiling, and the point at which the boiling is occur is called boiling point. So boiling point of different materials are given in this table, and you can see that the table is showing the name of substance hydrogen, which is boiling on minus 253. Very amazing. Minus 253 degrees Celsius is the boiling point of hydrogen, and similarly oxygen is boiling at minus 183, which is also very amazing. Ether 35 degree Celsius, alcohol 79 degrees Celsius, water 100 degrees Celsius, which we will observe today in greater detail that how. And mercury, very importantly, that is 357 degrees Celsius. That is very large temperature. So for your information, I told you that many different substances are having many different boiling points, which is quite clear from this table. First of all, let me define properly the boiling and condensation. What is boiling? I told you boiling is the change of state from a liquid into a vapor occurring at a constant temperature called the boiling point. Ladies and gentlemen, you will say that what is constant temperature? If I see this curve, then there is a constant temperature. The temperature is not changing during this period, and during this period the transition is taking place from liquid to the water. So that is why we are saying at a constant temperature, and instead of a constant temperature we can use a word at a fixed temperature as well. So boiling point can occur. We are not talking about the water in this particular, because this definition can be applied to many different substances and their boiling points are different. So we are generally defining this boiling point, and Boiling is the change of state from a liquid into vapor occurring at a constant temperature called the boiling point. On the other hand, what is condensation? As I told you, that this is the reverse process. But let us define it. Condensation is the process whereby vapor changes into a liquid at the same constant temperature. And that is what I told you. The temperature at which the boiling point is occurring must also be the condensation point. Heat is giving out Heat is given out during the condensation. Let's talk about the condensation in a bit detail, that what is condensation. Then we are coming towards this graph. Ladies and gentlemen, have you observed in the cold days of winter, when you are seeing the windows, glasses of your room, they are there, you are observing droplets of water on that glass. That is the condensation process. Vapors from our nose and mouths are going out, and cold weather is condensing that on the glass of the window, and as a result we are observing droplets. That process is known as condensation. Another, whenever you are going in your car on a long drive in cold weather conditions, then you are seeing that uh, uh, your glasses of the car becomes wet and you cannot see anything outside until you are not wiping it with your hands. That is also the process of condensation. When from our mouth vapors are going out, we are talking, or when we are breathing, then vapors are going out from our mouth and it is sticking to the uh, mirror of those or the glasses of that car, and it becomes condensed and then we cannot see any other thing. So that is also condensation. Another example is when you are putting the cubes of ice inside a syrup or inside the water, you can observe that from outside of the glass there are droplets coming down. They are trickling down from the surface, outer surface of the glass, and that is called condensation. It is not like this that water is going out from the glass outer side and they are trickling down. From the environment, they are condensing the vapors, and then they are trickling down in the form of water from the outer surface of the glass. One very important and the last example I can give this on, when sun is hitting the surface of water, it is changing in vapors and it is going down. When it reaches to the colder area of the atmosphere, it becomes the clouds, and those clouds on condensation, on cooling down, take the shape of droplets, and one by one that droplets are coming down to the earth again, and that is also due to condensation. So hopefully you have understood the concept of condensation, but let me put one question and you have to find the answer of this. Whenever we are seeing or listening the weather report on electronic media, we are hearing the term precipitation very frequently, that if there is a 50% precipitation in the air, there is a chance of light shower. If it is 80%, heavy shower is there. So my question is that whether precipitation and condensation yield the same concept, and this is a task for you. Learn it from the books, from Google, from wherever you want to search it, from YouTube, and then write the answer in the comment section so that I will understand that my students are working hard. If you are taking it lightly, then you are just passing your time and you won't be successful in achieving that high grade. So do whatever I am telling you. Okay, now coming to this curve which we had observed in the melting point. We started from ice and it comes down as a melting point, and then when we were giving more heat, this curve was increasing. So this is the process where the heat is being absorbed by the water and it is increasing the temperature, which can be visualized from the thermometer reading. So we are giving the heat to the water, pure water, and the temperature is rising in this xy part of this curve. So when it reaching the temperature to 100, still we are giving the heat to the water, but the temperature is not changing, and we can observe that from the thermometer reading where that heat is going. That heat is utilized in two ways. One way is that it is doing work against the attractive forces of intermolecular bonds inside the molecule. They are separating it. For the separation, we need energy, and that energy is coming out in the form of heat. One, the second thing is that heat is utilized to work done against the environmental particles to tackle it. When these water vapors are going up, it also need energy, and that energy is coming in the form of heat which we are providing. So during this period from Y and Z plateau, we are in a position that the water is boiling, they are separating the molecules, and when they are far apart from each other, now they are in a position to become free or independent from the attractive forces of intermolecular bonds, and they are going in the surrounding air in the form of vapors. One thing I must tell you here, that whenever we are providing the heat, that heat is not shown by the thermometer. So we are calling that heat as a latent heat, which is our next topic. So latent heat means hidden heat. The heat is hidden to be shown on the thermometer scale, and that latent heat is particularly known as latent heat of vaporization. That is, latent heat of vaporization means that it is a hidden heat which is converting the water molecule which is in the liquid form to a gaseous form or vapor form. So that is why they are called latent heat of vaporization. So uh, during boiling, the temperature remain constant at its boiling point. Heat is being absorbed by the substance. Keep that in mind, I told you. Now we are coming towards another topic. Just like we observed in the case of melting, can the melting point be changed by adding impurities to the pure water? Yes, we saw that there are antifreeze, salt, pressure, all those things were changing the melting point. Actually, they were reducing the melting point from 0 to -2 or -3, something like that. So can we observe these sort of phenomena in the case of boiling? So we will observe the effects of impurities on the boiling point of water. When we want to observe the boiling point of water, we were taking in account of pure water. No impurity was there. And when the water was pure, 100 degrees Celsius was the temperature at which the phase transition took place. Now, if we add sugar or salt to the water and then put that solution on the fire, and heat is being provided to those water, it will not boil at 100 degree Celsius. Might be it is boiling at 104, 102 and 103. Exactly in the same fashion, if we want to observe this phenomena, then we can take the water of sea, which is saline water. Saline water means that there is greater amount of salt inside that water as compared to the pure water. Pure water will boil on 100 degrees Celsius, while the uh, saline water is taking place for transition of state at higher temperatures. So yes, adding impurities to the water can increase the boiling point of the substance. So, yes, effects of impurities on the boiling point of water. Just we saw antifreeze. Here we can add the salt or sugar. So, in case of antifreeze, the cooling process was slowed down. In case of adding salt or sugar or any other material added to the water will increase its boiling point. So keep these things in mind that yes, if we are adding salt or sugar to the pure water, it will increase the boiling point. So it will increase the boiling. Increase means change the, I should write, change the boiling point. And that is true for condensation as well. When pure water is boiling at 100 degrees Celsius, it will condense also at 100. But if we are adding impurity to the water, then it will do what? It will change the boiling point as well as the condensation point. For example, if its boiling point is increased to 102 degrees Celsius, the condensation will also take place on 102 degrees Celsius as well. So, these are all the things, and that is a general question that whether impurities affect, yes, it affects. Now, affects, what are the things which can change the boiling and condensation points of the substance? So next topic is effects of pressure on the boiling point of water. Effects of pressure on the boiling point of water. Pressure increases, the boiling point decreases. Pressure reducing, the boiling point increasing. Keep this in mind. Ladies and gentlemen, have you ever observed on going to a high top hilly area, and when you want to cook something there, even an egg, it will take a larger time to boil. It will take, because the pressure of atmosphere is lower, that because they are higher than the sea level. The atmospheric pressure on the sea level is different with the altitudes. When you are going to the areas of high altitudes, there you will feel reduced pressure. So, first thing, boiling under reduced pressure. And let us examine this with the help of an experiment. There is a bell jar, which is this one. There is a cork here. in which there is a small pipe on which there is Borden gauge to record the pressure. It will tell you that whether the pressure is increased or decreased. This gauge is telling you. Inside this, there is a thermometer which is showing you that all these settings are at the room temperature. All the settings are at the room temperature. So there is a water inside a beaker. Very interesting phenomena we will observe here. There is a beaker in which water is there. In that water there is a thermometer which reads the room temperature, what is happening on. This is rubber tubing. This is rubber. One side of it is connected to this gauge and the other side of this is connected to vacuum pump pressure. What actually vacuum pump pressure is doing, it is dragging air. So when it is dragging air, the pressure will be reduced inside this jar. When the pressure is reduced, the bubble are forming inside the beaker and it is moving upward. Ladies and gentlemen, this is very interesting. We are not giving any heat and bubbles are formed. So when we reduce the pressure, it means that the bubbles are produced, means it start boiling at a room temperature. And those are the phenomena which we are observing at high altitude, even on the Mount Everest. So when we are going, water will be boiling, but the cooking will not take effect. It will take longer time to be cooked as compared to the sea surface. The sea level, the surfaces which is with the sea level. So that is the phenomena. When you are reducing this pressure, it will do what? It will do the uh, reduction of pressure because air being dragged out from this bell jar through these pipe systems, and there is a device which is vacuum pump reduces pressure inside, and on the reduced pressure they are boiling. So it means it will need high heat to cook the thing inside that. So that was the one thing. Next we will use the boiling point of increased pressure. Yes, I am leaving it for the next class, and we will observe that by increasing the pressure, the cooking time is reduced, and that is why we are using pressure cooker in our homes. With the less heat absorption, we can increase pressure on the system and it will cook very quickly. Ladies and gentlemen, thank you very much for watching. Allah Hafiz.